Hello friends, I'm Satyendra and today we are going to learn how to solve this question. This question was asked in GATE in CSIR NET 2013 June, and in this question they asked you to find the expectation value of the operator lx square plus ly square in the state, okay, in this state, okay. So the answer was 26 h naught square over 25, and let's see how to break this answer, okay. So in order to find the expectation, we know something that we have to apply, okay. So lx square plus ly square plus lz square equals to l square, okay. So this can be written like this, and then we will take the expectation on both these sides, okay. So it will become like this, and then this expectation can be written like this, okay. So instead of finding the expectation of this quantity, we can find the expectation of this quantity, okay, to bring our answer. So now let's see. So the expectation in the state psi is now can be written like this, okay. So here I am showing you how we are finding the expectation in the state psi, okay. So this expectation can be written like this, and this expectation can be written like this, okay, for the state psi. Now we will evaluate each of these terms separately, okay. So let's first solve this term, okay. So let's see how we can solve it. So now we are here. So in this equation I have substituted the value of psi from the question, okay. So it was given in the question here, and I have substituted the value of psi here, okay. So you can clearly see this, okay. Now in this step I have operated this L square over each of these basis sets, okay. Now in this question, now this equation is clear to you. And now in this equation, what I have done is that I have taken out all the constant terms. Like here it was 3, so I have taken out the 3 outside. So here was nothing constant was there, so it was kept as it is. And here root minus under roots 15 was constant, so it was taken out, okay. Now in this now let's see to this question, to this equation, okay. So in this equation I have solved this part, okay, this part and this part. And see, to solve this part I have used this basic equation. This is the eigenvalue equation for the L square operator, okay. So when you use this equation, your L comes from the base from your wave function L here, okay. So if you are unaware of this equation, you can remember this equation for future, okay. So I have used this equation to solve this thing, okay. So you can see that I have clearly written it here, okay. Now in this equation I have solved this thing. So this thing becomes 2h naught square, which is a constant value, so that is taken out, and we are left with this thing, okay. Similarly I have done here, and I have done it here, okay. Now you can see that, okay, I have substituted the value of psi from the question, okay, here also and here also. So the resulting equation becomes like this. It becomes a big equation, but it is quite easy to solve, okay. So now in this equation I have to operate this thing into this thing, okay, and then this thing into this thing, and then this thing into this thing. Since the subscript for this and this are the same, so when we operate on this, that will give you 1, okay. But when you operate this on this, that will give you 0 because of the orthonormal property, okay. So you have to operate this on this, and this on this, and you have to operate this on this only, okay. So you can see that when I have operated this on this, so I got this thing. When I operate this on this, then I got 0 because the subscripts were unequal. And then I operated this on this, so I again got the 0 because the subscripts are not equal, okay. So that is because of this orthonormal property, which I have already written here, okay. Now in the similar fashion you can get this, and you can also get this thing, okay, in the similar fashion. Now in this equation I have solved this question, I have solved this equation, okay. So in this equation this is simply 1, okay, because the basis sets are normalized, Okay, so this is 1 and this is also 1 and this is also 1, which I have written it very clearly at this equation. Okay, okay, now it is quite easy to solve this equation. It is simply a mathematical equation, and you can simply go through these three equations and you can easily find that it becomes 50 h naught square over 25. Okay, so it becomes 50 h naught square over 25. Okay, now we will solve our this part. Okay, okay, now in order to solve that part, I have substituted the value of psi from the question in this equation. Okay, and now in this equation I have taken only the, when I operate this on this, then I take only this one and this one because their subscripts are same, and also the space sets are normalized, so I can only retain this term and I can leave the other terms. Okay, similarly when I will solve this equation, I can use this one and this one and this one, so in this fashion I get this equation. Okay, or if you don't understand this method of doing, then you can follow the earlier method that I have used here for this. Okay, so okay, so now in order to solve this equation, you should remember that you should have to know that the expectation of the L square in this state is given by this equation. Okay, so I have used this equation to solve this this thing. Okay, so when I solve this thing, this simply gives m square and h naught square. Okay, so I used this equation. So for this here the m is equals to, so this here y is n, l and m, so the last term gives the m, so here the m is 1, so 1 square and h naught square will be the answer of this quantity, and that is given because of this. Okay, so in the similar fashion I can evaluate this and I can also evaluate this, so it is very clearly written at this point. Okay, now this equation is clear to you. So now I have simply solved this equation. It was the mathematical equation and I have solved it, and I simply got 24 h naught square over 25. Okay, now we also have to evaluate this quantity because that was also in our equation. Okay, so we also have to solve this quantity. So let's see, we are see I have solved it. Okay, and while solving it I have taken this term and this term, and then this term and this term. Okay, and then this term and this term. This is, I have taken this because their subscripts were same, and when their subscripts are same, this product was simply 1, and that's why I have taken this, and when their subscripts are unequal, they are 0, that's why I have not written them. Okay, now you can see it very clearly here that this is equals to 1, this is equals to 1, and this is equals to 1. Okay, at this point it is quite clear to you. Okay, now I simply solve it. It gives 25 upon 25, that is 1. That means the wave functions were normalized. Okay, so now I finally substitute all the values in this equation. Okay, in this equation, so I have substituted the values here in this equation, and I have solved it, and I have got 26 over 25 in, okay, into h naught square. So this is your answer. Okay, if you really like this video, then friends please like, share and subscribe our my video and my channel. Okay friends, thank you very much.